Mars, the red planet. A complete overview. Mars, the fourth planet from the Sun, has long fascinated scientists, astronomers, and space enthusiasts. Known for its distinctive red appearance, the planet has been the subject of extensive exploration, as it holds clues about the past and potential future of life beyond Earth. This article provides an in-depth look at Mars, covering its physical characteristics, atmosphere, surface features, climate, exploration history, and the possibilities of human colonization. 1. Basic facts about Mars. Mars is the second smallest planet in the solar system, following Mercury. It has a thin atmosphere and a cold, desert-like environment. Below are some key planetary statistics. 1. Diameter 6,779 km, about half of Earth's diameter. 2. Mass 642 or 123 kg, about 10.7% of Earth's mass. From gravity 3.71 m less to 38% of Earth's gravity. From 4. Distance from the Sun 227.9 million km. Orbital period 1 Martian year. 687 Earth days. 6. Rotation period 1 Martian day or so. 24.6 hours. Number of moons 2. Phobos and Deimos. Yaktan 8. Average temperature 63 degrees. Can range from 140 degrees at poles to 30 degrees near the equator. 2. Mars atmosphere and climate. Mars has a very thin atmosphere composed mostly of carbon dioxide, CO2. Unlike Earth's atmosphere, it does not retain heat efficiently, leading to extreme temperature fluctuations. Atmospheric composition. 1. Carbon dioxide, CO2, 95.3%. 2. Nitrogen, N2, 2.7%. The argon, R, 1.6%. For oxygen, O2, 0.13%. Water vapor, H2O, 0.03%. The thin atmosphere makes liquid water unstable on the surface, though evidence suggests that Mars had flowing rivers and lakes in the past. Seasonal dust storms are common, and some can engulf the entire planet for weeks. Surface features of Mars. Mars has a geologically diverse surface with vast plains, deep canyons, and massive volcanoes. Major landforms. Olympus Mons, the largest volcano in the solar system, towering 22 kilometers, 3 times the height of Mount Everest. Vatran 2, Valles Marineris, a massive canyon system stretching over 4,000 km, nearly the width of the United States. The Tharsis region, a volcanic plateau with some of the tallest mountains on Mars. Or Hellas Planitia, one of the largest impact craters, about 200-300 km in diameter and 7 km deep. With polar ice caps, consist of frozen carbon dioxide, dry ice, and water ice, expanding and contracting with the seasons. These features indicate a history of volcanic activity, water flow, and tectonic processes that shaped the planet's landscape. 4. Water on Mars, past and present. Scientists have found strong evidence that liquid water once existed on Mars billions of years ago. Signs of ancient river valleys, lake beds, and mineral deposits suggest that Mars had a warmer and wetter past. Recent discoveries. NASA's Curiosity rover detected clay minerals and sedimentary rocks, which form in the presence of water. The Mars Reconnaissance Orbiter found underground lakes of liquid water beneath the polar ice caps. Were seasonal dark streaks called recurring slope lineae. RSL suggest the presence of salty liquid water. The search for water is crucial because it increases the possibility of past microbial life and supports future human exploration. The Mars moons, Phobos and Deimos. Mars has 2 small moons, Phobos and Deimos, which are irregularly shaped and resemble asteroids. Phobos, the larger of the two, orbits Mars very closely, only 6,000 kilometers above the surface. It is slowly spiraling toward Mars and may eventually break apart or crash into the planet. Deimos, the smaller moon, orbits farther away and is thought to be a captured asteroid. These moons are of interest for future space missions, as they could serve as bases for exploring Mars. 6. Exploration of Mars. Mars is the most explored planet after Earth, with numerous missions from NASA, ESA, ISRO, and other space agencies. Past and present missions. On Mariner 4, 1965, first spacecraft to capture images of Mars. 2 Viking 1 and 2, 1976, first successful landers to analyze Martian soil. The Pathfinder and Sojourner 1997, first successful rover on Mars. 4. Spirit and Opportunity 2004, explored Mars for years, finding evidence of past water. Curiosity 2012, present, still active, studying Mars geology and climate. 6. Perseverance 2021, present, searching for signs of past microbial life and collecting samples for future return missions. Future missions, including NASA's Artemis program and SpaceX's Starship, aim to send humans to Mars within the next few decades. 7. Possibility of human colonization. Mars is the most promising destination for future human settlement due to its similarities to Earth. However, colonization presents major challenges. Challenges. Extreme cold. Most of Mars is below freezing temperatures year-round. Within atmosphere cannot support human life without artificial habitats. Top 3. Radiation exposure. Mars lacks a strong magnetic field, exposing the surface to solar radiation. Limited resources. Requires advanced technology for sustainable food, water, and oxygen production. Solutions and future plans. Terraforming. The idea of modifying Mars climate to make it more Earth-like by releasing greenhouse gases. SpaceX's Mars mission. Elon Musk's vision for a self-sustaining colony using Starship spacecraft. Shade 3. NASA's human mission. Planned for the 2030s, focusing on short-term exploration and research.